Hey guys, this is NerdNick, and I'm going to be bringing you a tutorial on how to design Dollar Tree foam board airplanes, starting with just an image from Photoshop. I'm going to be covering the techniques I use, as well as the tools, and really just try to give you a good foundation to step into doing this yourself, whether you're using Photoshop or Inkscape or something else. This process should work the same. There's nothing necessarily special about Photoshop. I'm just used to it, and so I'm going to go ahead and use that as my my platform here. So the first thing that we're going to do is we're going to locate a plane. We're going to pick a plane that we want to design. I really like the de Havilland DH88. I think it'll be a cool addition to my speed planes, and just a fun looking plane just in general. I have not designed or built or even flown a twin engine plane before, so this will be a new challenge. I plan on documenting all of it just as I go through it, to show you how this works. I've designed a few planes so far, I think 4 now, using these same techniques, and they've all flown and built very well, so the process does work, and we can jump right in. So as I said, I've picked the de Havilland DH88, and this is a image just off Google. I just searched DH88 plans, looked at what I thought to be the most reasonably scale looking image that had the views that I need, as well as clear detail. This image is not super big. It's like, I think it's 1024 pixels, so this is full size that you're seeing right now. It's plenty big enough to give me the detail that I need. One of the key things that I needed to see, or you need to see when you're looking at plans, is you need to be able to see a side view to determine the fuselage length as well as the vertical stabilizer size. You also need to see a top view. This is going to be for your wing. You need to know the aileron size, you need to know the wingspan, so that's really important. I also need to see a front view, just so I can see dihedral or any other, how does stuff line up. So by looking at this image, I know about how high off of the wing that the horizontal sits, as well as how much dihedral in terms of degree. This will also tell me where my props are going to sit and everything. So this image is really important. This underside image is not necessarily so important. If the plane has specific features that need to be seen, this is kind of key, seeing the bottom of where the engine pods are, but not super critical. The other really important part that isn't necessarily included in a lot of images is the sections here. So we see A, B, C, D, E, F, and then a marker here. This tells us the fuselage shape. So this is key, because just looking at an image without these pieces, it's really hard to know how to design your formers to get the right shape. You can just guess and make it kind of a oval or half circle, but you're not really going to capture the look, the feel of the plane. So these are really key when you get to the step where you're designing your poster board formers and everything, so that you have that unique shape, right, to really capture what does the plane look like. So this image was selected for those reasons. When you're looking at an image, I would look for something very similar. You're going to need all of those pieces to be able to accurately design the plane, right? If you're going for scale, or if you're going just for looks or whatever, you need something to reference, something to start with that has those details. So the next thing I'm going to do is I want to try and figure out how big do I want to make this thing. Most planes, and if you're looking at a flight test style power pod, fit around the 40-inch wingspan. They're kind of designed to fit around that. You can go bigger, you can go smaller, but airplanes have really been figured out in terms of the dimensions, and you're looking at a pretty standard airplane, you're going to fall into a very similar proportional kind of scale, and so that's a great place to start. I think I'm going to shoot for that with this plane. The only thing that this might limit us on is prop size. If the plane is too small, your props are going to hit the main fuselage here. If it's too big, then so I don't know yet. I don't know what that's going to look like, but I'm going to start with 40, and then we're going to go from there. So to do that, I have in my other document here, I have a flight test power pod, just copied from one of their plans and then put here. What I'm going to do with this is I'm going to copy it, just doing Control C here. You can edit copy, and then I'm going to go back to my main document here, and I'm going to paste it in. And this is going to give us a scale idea. So right now, the power pod is huge, right? The power pod dimensions are much bigger than the image that I have, which is it's not going to work. So I need to increase the size of my reference image so that it matches up with my power pod size, because the power pod scale is really what I'm going to build around to understand, you know, how big do I want the plane to be. So the first thing I need to do with this image is I need to increase it. I have no idea how much yet. We're going to figure that out. So if I go up to my image size, most images when you download them from, you know, online or whatever, they're going to be resolution of 72. This is not ideal, and it really is going to be part of the reason why the image is so small. Everything needs to be increased. So 300 resolution or pixels per inch is really what you want to look at. And if you look at the size here, if I start with 72, the width of the image is 1024. If I go to 300, it's much bigger. There's more information there now. I'm not really adding detail. I'm really just blowing it up because the image wasn't created at 300 dpi or pixels per inch. Sorry, yeah, pixels per inch, not dpi. So I'm just making it bigger. I'm not making it any clearer or anything. It will be blurry at full size because I'm just stretching it. But this will give us a much closer size. So there you see it's huge now at 300. 300 is what is kind of a standard. That's what the flight test plans are based on. That's what my plans are based on. And it's now we're on the same scale. And so when I look at what is a centimeter on the power pod to what is a centimeter on my reference image, so there's 1 centimeter. If I go over here, that's also 1 centimeter. Right. So those are actually the same size when I bring over the image now. So if I'm going to go ahead and do that here, I'm just going to copy this back over and paste it. And now it's much smaller. It's still way too big, right? So we have the right DPI. I'm sorry, I keep saying DPI. I apologize for that. We have the right pixels per inch at 300, but we need to make the image bigger still. So what I'm going to do now is I'm just going to go up to the image size and I'm going to increase it. By how much? That looked, based on the image of the power pod, it looked like it was still significantly too small a reference image. So it's at 4,000 width right now. I'm just going to jump to 8,000 and see what that does. So I'm going to increase that, shrink it back down a little bit so I can see 12% zoom. So it's getting pretty big. I'll go ahead and copy this again, paste it over, and we see the power pod is still, it's kind of hard to see, it's very faint, but it's still longer than the entire fuselage of the plane. So we're not quite there yet. We're going to do this again. We're going to image size, and we went from 8,000. Let's jump even more. Let's do 12,000 now. Okay, and I'm going to go ahead and paste in the power pod again. Zoom in here to get a little better idea of how big it is. And smaller than the size of the plane, but still, as you can see, it's much too big. So we're going to drop back one more. Go back to image size. Let's jump even more. Let's do 18,000. And we're going to paste it in. And now we're getting a little closer. So there's the power pod, and this would actually be about right if I was going to put the power pod inside the fuselage. Now this plane has, you know, 2 motors and they're on the side. This is not going to fit with a normal power pod. It's just too long. I think the plane would be way too big. Let's see what we're looking at right now, just as a general. What's the wingspan on this thing? Yeah, 96 centimeters. So we're getting there. That's almost 40 inches if I'm doing my math right. Actually, let's just make this easy. What is 96? 96 inches. Yeah, almost. So 37 inches there for that. So we need to make it a little bigger, but even then, the power pod's going to be significantly too big to fit on the wing. So let's go back to our image size step here in the history. Yeah, by the way, so what I'm doing over here, instead of undoing my changes or deleting new layers that I'm creating because of my pasting and everything, I'm just stepping back to the last image size so that I lose the layers over here and I don't have to do anything else. I'm just taking it back. As soon as I make a next either line or move or change, this history will go away because we're starting a new line. but I just need to get back to this size. So we're going to make this even a little bit bigger. So we're going to go back to image size. We were at about 37 inches wingspan, and we're going to go for around 40, right? So let's jump to 20,000. Now, one thing you notice too is that this is getting really big. This is a huge image. When you look at then the size that Photoshop is estimating it is, we're getting in the hundreds of megabytes for just this image, right? So if you don't have a decent computer, you might have some slowdown issues when dealing with these large files, especially when saving them or doing large edits. Once we get the plans laid and the lines going, it's a very small file. We're dealing with very small information. But here, just to get the reference going, the file's going to be huge. It's really going to be very big. Okay, so let's just quickly look at our wingspan. 106, so that should be over 40 now. Let's just double check. Yeah, 41. So that's a good starting spot. Let's go back here now. Let's put the power pod in. Make sure I have it copied. And let's take a look. So yeah, still too big, but we're getting. If I look at the fuselage width, the plane itself. There's no way you can make a perfect curve, with this technique, and we're not trying to. We just want it to be really close. The motor is going to sit on the nose of the power pod here and then extend out, so you have to kind of account for that. But usually where they have the nose cone and stuff on the plane, if you put it right there, you can assume that would be a safe spot to start with. And then the sides of this power pod actually sit up on top of the plate, so the plane is really only going to be as wide as this inside line. Okay, if you went with this dimension and everything, which is not bad. Again, you're never gonna get it perfect with this technique, but you can get pretty close. And this, what I would say, is pretty close. We're right about 40 inches wingspan, and the fuselage is lining up pretty good in terms of the width. Now, we're not using the power pod here. I'm just kind of giving this as an example because you probably will be designing a plane that's not twin engine for your first one. And like I said earlier, most planes proportionally line up about right. About 40 inches wingspan is going to put the power pod at the fuselage just right about the right size for the power pod to fit in there. Flight test guys did a pretty good job at standardizing that. There are exceptions, of course, depending on the plane, but that's a good place to start. If it's a normal 2-seater plane, 40-inch wingspan is going to be a safe bet for the power pod to fit. It's going to look proportional too in terms of the width and everything. So I'm happy with this wingspan. I'm happy with this power pod, placement, size, and everything. So one thing I'm curious about though is if I were to put the engine or the motors right here, what kind of clearance do I have for a prop? If I go off this, I probably could go a little further in, but that's 15 centimeters. I'm not good at math, and so I'm not going to try and guess. That's only a 5.9-inch prop. That's pretty small. I think a 7, probably, depending on the motor you're going to be using, might be more realistic. So if I wanted 7 inches here, I need 17 centimeters, roughly, right? So this line, 17 centimeters is about that big. So that would give us, I probably could fit a 7-inch. I don't know if that's too close. Maybe it is. I don't know. The plane should end right about here, right, with the width. So that probably okay. So this might be alright to use a 7-inch prop. If you have a little higher KV, you'd be okay. Yeah. So one of the other things that I want to talk about now, just before I end this first part of the video, is what are the tools I'm using right now just to even measure. How am I doing this, measuring and everything? So really all we've done is we've selected an image, we've increased the pixels per inch to 300, and then we found roughly the wingspan and everything that we want, right? No real tools have been involved yet in terms of doing anything, but the measuring that I'm doing, I'm using the line tool over here, and I have it set so that it's 10 pixels. So that's the width of the line. If I were to increase the weight of it, I could make it very wide, right? So now I have a very fat line, right? So this is something that you can play around with. I like 10 mainly because it's a solid size. Flight Test uses a much smaller. The power pod here is like 2 or something. It's very tiny. 10 is a good. It has a good amount of width to it. but it's also, you know, it's easy to see and everything. So 10's good. And I'm just clicking, and if you just click in free move, you have any angle you want that's visible here on this little indicator. It tells you what angle and how long. If you hold down the shift button, it will lock to the axis. So I can do 90 degree, I can move it up a little bit, jump to 45, or straight up and down, right? You can go around and it'll lock to that degree. That also works if you're spinning an image, which we'll get into later, but you can rotate an image on that axis, which keeps things nice and uniform. One of the things that you'll want to do as we move forward is do something consistent, right? You don't want to draw a line that's at an angle and then try to draw another line that's the same angle. It's very hard to line them up and make them the same. So it's better to start with two 90s and then rotate the whole thing together, which again we'll get into more later, but the line tool is really going to be one of your main tools that you'll use, and knowing the shift, click and drag is really important. So again, I'm just clicking, holding down shift to lock it, continuing to hold shift while holding down my left mouse and then letting go to then save that line. Alright guys, so for now this is going to be it for the part 1, just kind of covering image selection, what are the key things you want to look at when selecting an image, looking at proportions, right, using the power pod, and then also the line tool, just a basic introduction there to that. So this is going to be part 1. Stay tuned guys for more parts. I don't know how many parts it'll be, but part 2 and plus in the future. Thanks guys for watching.